given the curve equation y equals x e to the 2x plus 5e to the negative x. This curve has a minimum point. Part A, we are to show that the x coordinate of the minimum point satisfy the given equation here. To find the x coordinate of the minimum point, that would be the critical value of the function. Critical value occurs when dy dx is 0. So we find dy dx first. And for this first part here, x times e to the 2x, we differentiate this by applying the product rule, keep x and differentiate e to the 2x. That will be e to the 2x times 2. And now when we differentiate x, we get 1. Then we keep e to the 2x. For this part here, we have 5e to the negative x times negative 1. We have to apply the chain rule because of the negative x. dy dx is 2x e to the 2x plus e to the 2x minus 5e to the negative x. Critical point occurs when dy dx is 0. So we set dy dx to 0. We have 2x e to the 2x plus e to the 2x minus 5e to the negative x. 5e to the negative x is also 5 over e to the x. And in order to solve this, we multiply throughout by e to the x, so that we have 2x e to the 3x. E to the 2x times e to the x, the exponent you just add to obtain 3x, plus e to the 3x minus 5 equals 0. Now we want to solve for x. You see that you have e to the 3x for the first two terms. We can factor e to the 3x. We have 2x plus 1 and move the 5 over so that we have 5 on the right side. Then in order to show that it satisfies this equation, but from this equation, you do not see an e, meaning that you have to log throughout. So taking log, we have log of e to the 3x times 2x plus 1. That is log 5 as well. And because we have a product here, so by applying the product law of logarithm, we have ln e to the 3x plus ln 2x plus 1. We can write this as 1 plus 2x as well. This is ln 5. Now ln e to the 3x, that is just 3x. So ln e to the 3x is 3x. And we keep the rest, 1 plus 2x equals ln 5. Now move ln 1 plus 2x over to the right side. We have 3x equals ln 5 minus ln 1 plus 2x. Dividing throughout by 3, x is 1/3 ln 5 minus 1/3 ln 1 plus 2x. That is what we need to show in part A. Part B, based on the equation in part A, we need to find the x coordinates of M correct to 3 significant figures. We are to use an initial value of 0.35, and the result of each iteration is correct to 5 significant figures. We can let x sub n plus 1, we use this part here from part A, equals 1/3 ln 5 minus 1/3 ln 1 plus 2 x sub n. And we let x naught to be 0.35. then x sub 1 is 1/3 ln 5 minus 1/3 ln 1 plus 2 x naught. This x naught we will replace with 0.35 and using and then just get your calculator, and we have 0.35960 to 5 significant figures. Then x sub 2 here is 1/3 ln 5 minus 1/3 ln 1 plus 2 x sub 1. Again, this x sub 1, we replace this with the value we found just now, which is this, 0.35960. And that gives us a value of 0.35586. So to 3 significant figures, we have not reached convergence. Then we find x sub 3, that is 1/3 ln 5 minus 1/3 ln 1 plus 2 x sub 2. This x sub 2, we use the value we found just now, and x sub 3 is 0.35731. We have to continue this, find x sub 4, we are 1/3 ln 5 minus 1/3 ln 1 plus 2 x sub 3. Now, again, the x sub 3 is replaced by this value. X sub 4 is 0.35675. To 3 significant figures, x is 0.357.